This video tutorial will explore a workflow for consideration of cracking when checking vibrations in Adapt Builder. We're going to go ahead and use Adapt Builder version 20, and we'll select the option here for RC mode and Floor Pro. We're going to be using just an elevated structure. So we'll go select OK. And the next thing we're going to do is just build a very simple model. We'll go to the floor wizard. We're going to do a 3-bay by 3-bay, and we'll say the bays here are 28.5 feet in both directions. And we're going to say that the slab thickness here is 9 inches. We'll go through and just select next until we have the slab. Now we are going to increase the live load just so we can force cracking on this slab. So we're going to bump this up to 80 pounds per square foot, and we want to make also sure that we have under loading combinations, we're going to add just the default cracked and long-term combinations here. So we have one combination set to crack, which is the sustained load. This includes 1/3 of the live load, and the long term is just 3 times that sustained solution. We're really not looking at the long term, we're more focused here on the cracked deflection combination. And the user could set up multiple crack combinations to take care of, for example, staging of loads, construction loads, maybe into service loads, to predict different levels of cracking under certain load conditions. The next thing we're going to do is under analysis and vibration settings, we can set up our combinations here to produce the mass for the particular vibration combo. So here we're just using the self-weight only. We can set the number of modes for each of the vibration in terms of the solution. And once that's done, we're going to mesh the structure. Once the mesh is complete, we'll go ahead and analyze the structure. So we're going to select the option here, and I'm actually going to produce a solution for the vibration so we can compare results. And notice that the applied stiffness modifier, this is called the usage case, this is set to uncrack, so nothing is assumed to be cracked under this first run. We're going to then design the design strips to get the reinforcement and then check the crack deflection based on that. So we'll go ahead and start this process. Once that's done, we can just jump over here to the result browser, and from the vibration option we're going to go to the first mode just to compare, and you can see this is based on the full structure. The frequency is 6.26, period is 0.16 seconds, and then you can also explore additional modes here, but we'll make sure we kind of keep this number here in mind, 6.26. We're going to soften the slab in terms of the cracking once we get to that portion, and we'll compare that back against these numbers here. So let's go ahead and turn that off. We're going to go to the next step, which will be to floor design. I'm going to generate my design cuts, and you can see there are cuts in both directions, the X direction as well as the Y direction. Now these are based on full tributary, so if we wanted to include middle strips, that's simple to do. We'll go back here to the dynamic editor under the floor design ribbon, and we're going to go to middle strips, create middle strips. That automatically produces those strips, and I'll generate the section cuts again, and now we have middle strips and column strips in the slab. So let's go ahead and design the cuts. This will allow us to gather the reinforcement in the slab that's calculated for the design under the combinations we have set and under the loading. Okay, so we'll calculate that. If I wanted to produce that reinforcement, I could calculate the plan, which basically just shows it graphically on plan. That's easy enough to handle, and then we'll go over here to analysis again. I'm going to now run the crack deflection analysis. So we're required to analyze first under uncracked, design the strips to gather our reinforcement, and then run the crack deflection analysis, and that's been done also. So if we go back to the result browser, under the loading menu here under load combos, there's this crack deflection option. So the sustained load using I gross for the deflection of this slab, the deflection you can see max is about 0.51 inches out in these outer bays, mid panel. And if we go to the cracked solution, the cracked is 0.61. So we're getting some cracking in the slab. To what extent? It's easier to tell if we come back here under the cracked solution. If we select cracked and then come over to the slab actions, we can see the reduced stiffness about the X direction and then about the Y direction. And you can see that if we kind of highlight this, we have these panels really along the column strips, let's say, in both directions, where if we look at that, we're losing, roughly 60% of our stiffness there. If we look at that ratio, that's I effective to I gross, and looking at the other direction, it's roughly the same. So what we're going to do in this case is we want to go ahead and we want to assign modifiers to those column strip panels. But in order to do that, I can't have just one slab region. I have to break this into multiple slab regions. And so what I'm going to do is I'm going to go ahead and, using kind of this as a guideline, I'm going to draw in some construction lines. And this is a fairly rough way of doing it, but it's one alternative way of handling this. And you could get more, more accurate by developing more slab regions versus what I'm doing, which is just kind of broadly developing these regions. But I need some guidelines in order to do this. So I'm just using the contours to produce this type of a result. Okay. Once that's done, I'll turn off my reduction in stiffness. And now what I'm going to do is I'm going to go in and put in, let's say, slab regions in each one of these quadrants, if you will. So we'll go to model, slab, and we're going to turn on the snap tools. I'll turn on snap to intersection also. And we're just going to snap and create slab regions here. And each one of these slab regions I can then go and I can assign a unique modifier to for bending or for axial stiffness. So we'll go through and do that, and then we'll come back and look at how we can handle the modifiers. So what I'm doing here is I'm actually drawing in one strip this way. This is not to indicate it's a one-way slab, it's just a strip, and here. And then I'll fill in, let's say I'll fill in this panel here, and I'll fill in this panel here. So basically I cannot have overlapping slabs that are of the same thickness and the same offset. So none of these slabs are offset. They're all going to be 9 inches. And so what's going to happen is this slab, I'll just kind of hatch the area that's going to be reduced. So we have this region and this region here, something like that. So those are going to be our slab regions. Okay, and let's go back and just finish out modeling those. We have one there. Okay, and sometimes it's easier to work around the line, so I'll just delete them, get those out of the way. Now this area kind of right in the middle technically did not need to be reduced, but I'm going to reduce it anyway just for sake of the example here. So what I'll do now, I'll just double click on one slab. And by the way, I need to go back and delete out that main slab. So I've deleted that slab out. Now we have a bunch of slab regions. And if I double click on one, I can set stiffness case. So I'll just go to this, I'll click on this plus sign, and I'm just going to call that cracked. Okay, we'll call that cracked, and then I'm going to use user or custom modifiers. So for M11 and M22, I'm going to say those are 0.4. So we'll say comma, let's see, 0.4, 0.4. I'm not going to reduce the axial stiffness in this example. So once that's done, now each one of those can be set to that particular modifier. So if I just Windows select the slabs, let's say, let me do it this way. I'll select there, press Control, and then Windows select that. I can just go and, I should have done this originally, but let's say 0.4, 0.411, something like that. Okay, and if you double click on any of these just to confirm, go to stiffness modifier, you can see the modifiers there. So now that we've done that, we've kind of identified the regions that are cracking. We're just going to re-mesh and then reanalyze. So we'll go ahead and we'll mesh this again. I have to mesh because I've changed the slab boundaries. And then we'll reanalyze for vibration included, and we're going to change this now to cracked. So this is now the cracked usage case that I just defined. We'll run this, and originally we had the 6.26 frequency for mode 1 based on our vibration combos that we're looking at. If I now look at this, you can see the frequency obviously is quite a bit different due to the change in the stiffness of the system. So we're now looking at a frequency of around 3.47 hertz. If you have any questions about the process, please let us know. You can contact us at adaptsupport@risa.com.